All right, everybody. This is a bonus lesson. Normally we would do Rolle's theorem and mean value theorem, but because of the COVID, we are kind of skipping some stuff. So this will not be tested, but if you're going on, it's good to know this, although they will go over it next year for you. So this is Rolle's theorem here. So I should have titled that Rolle's theorem. Says if f of x is continuous on the interval ab, it's differentiable on the interval ab, and f of a is equal to f of b, then there is at least one number c in ab such that f prime of c is equal to 0. Okay, what the heck does that mean? It means this. This is a, this is b, and that's f of a, and it's the same as f of b. As long as the function is continuous and differentiable, and there's one number c such that f prime of c will equal 0. In other words, the slope will be 0 at that point, as long as these are the same. Okay, as long as these are the same, because the slope between these 2 points is 0. If you come back to the same level, there will be some peak that will equal 0, which makes perfect sense. All right, that's Rolle's theorem. Now, if you take that and you tilt it, you get the mean value theorem. So the mean value theorem is one of the most important in calculus, and it's used in a lot of proofs. And if we were not doing all this online and we were back in school, I would have shown you, and I still might show you a couple of times where you can use it to prove fixed points. Okay, so it says, pretty much it's pretty close. If f of x is continuous, everything has to be continuous. No jumps, gaps, asymptotes, anything like that. On AB, and differentiable on AB as well. Then there exists a number c in AB on the interval such that f prime of c is equal to f of b minus f of a over b minus a. And if this formula looks familiar, this bit right here is basically y1 minus y2 over x1 minus x2. Your grade 10 slope formula. Okay, so basically it says that as long as you are continuous and differentiable, there will be a number on your interval where the derivative of that number, i.e. the slope, will equal to the slope of the two endpoints. So again, visually much easier to realize. So we have A, we have B. Rolle's theorem, they were the same numbers, so the slope here was 0. In the mean value theorem, they do not have to be the same numbers. So it doesn't matter what the graph does as long as it's continuous and differentiable. If you take the slope of this line, which is, this is the slope formula here right above it, that it will equal, call that C, slope at that point there. The slopes of this line and this line will be the same. All right. So in other words, we can say do this in a different color. I want to put this in a little more layman's terms, i.e. the slope of the secant line between AB, this line here, is parallel to the slope of the tangent line, parallel to the slope of the tangent line at another point C. Alright, so the slope between the two endpoints, this line, will equal the slope of some at least one other point on the graph. There could be others, but in this case, it's just one. Alright, if you want a practical example of how this works, you can look in the book. 173, there's a police car example. It's actually pretty good. But I'm going to show you the more mathematical stuff you would be expected to know how to do. I've already written the questions out, and here they are. Determine if the mean value theorem, MVT, mean value theorem, can be applied to the following functions over the domain given. If the MVT is applicable, then determine the value of C which satisfies the mean value theorem, and if it is not valid, please explain why. Okay, here's our first function. X plus 1 over the domain negative 1. The MVT is not applicable. Why not? It is because there is a undefined point, f of x is undefined at x equals 0 as a vertical asymptote, and that is in the middle of our domain. So remember, for the MVT to work, it has to be, continuous and differentiable. Okay, so let's go to the second one. F of x is equal to the absolute value of x minus 6 on the domain, all right? That is a continuous function, so we're good there. However, think of x minus 6. There's 6. Looks like this. That is a sharp turn, which hopefully you remember means the derivative does not exist at that point. Okay? So MVT is not applicable because it is not differentiable. That's what this part means. Differentiable means the derivative has to exist everywhere. So MVP not applicable. Okay. So let's look at one where it is applicable. F of x is equal to x to the fourth minus 8x on the domain 0 and 2. No undefined points, no sharp turns, it's a straight up polynomial function, and if you remember, all polynomial functions are continuous. So basically we can write out what the MVT is. There's your MVT, so write that out. So basically, f prime c will equal to f of b minus f over b minus a. Okay, so let's find, well, first of all, we can say f of c is going to be c to the 4 minus 8 times c. So f prime of c would be 4c cubed minus 8. So that's going to go in right here. This FB, well, A and B are these things, but it's actually which matter what you call A and B. So we can go 4c cubed minus 8 equal to f of b, which is 2, minus f of 0 over 2 minus 0. Okay, so what's f of 2? Well, put 2 into the function. 2 to the 4 minus 8 times 2. 2 to the 4 is 16. 8 times 2 is 16. So it's 0. F of 2 is 0. So we have 4c cubed minus 8. So 0 minus, now if I put f of 0 in there, I'm going to get 0 to the 4 minus 8 times 0, which is 0 as well. Makes our life a lot easier. So top of 0 over 2, so it's just 0. I end up with 4c cubed minus 8 is equal to 0. Move the 8 over, divide off the 4, so c is equal to the cube root of 2. That's it. If you wanted to find the y value of that, just plug it into there. But I don't actually care. I was just asking for the c value, and that's it. All right, that's the mean value theorem and Rolle's theorem. If you're looking for some practice questions, page 174, number 31, 33, 37, 39, 41, 43, and 45. This otherwise is known as 37 to 45 odd. All right, everybody, that's it. That's first bonus question or bonus video. Good luck.